Hello everyone, my name is Dr. P.M. Jyosthna. I am working as an associate professor in the Department of CSE at B.V. Raj Institute of Technology, Narsapur. Today I am going to discuss about substitution techniques. To understand the substitution techniques, we should know few terminology, that is encryption and decryption. Then we will discuss about the three substitution techniques, that are Caesar cipher, monoalphabetic cipher and playfair. What is encryption? Encryption is a process of converting plain text to ciphertext. What is decryption? Decryption is a reverse process of encryption, that is converting ciphertext to plain text. That we can observe in this diagram. So in this diagram, source side part is called encryption process. At the destination part is called decryption process. In encryption, converting the plain text X to ciphertext Y. At decryption process, converting ciphertext Y to plain text X. So for this transformation, both the sides they are using the encryption algorithm, and at the destination side using the decryption algorithm. It is also the same algorithm used at the encryption side but in reverse process. These algorithms use a secret key K. So the encryption algorithm is using secret key K to transform plain text to ciphertext. In the same way, the decryption algorithm uses the same secret key to transform ciphertext to plain text, so that the entire communication is secure as long as the key K is secure. So both source and destination must share the secret key K through a secure communication channel. So from this we can understand that to perform the encryption or decryption, the people requires a key. The entire security relies on key. Now let us discuss our today's lecture, substitution techniques. These substitution technique, we can say it as one of the building block of encryption techniques. So we have two building blocks of encryption techniques, that is substitution and transposition. Substitution is a replacement of a plain text letter with another letter or symbol or numbers. So it is just replacing plain text letter with another letters or with another symbols or numbers. So this process is called substitution technique. So let us see the first basic substitution technique is Caesar cipher. So Caesar cipher replaces each plain text alphabet, each plain text letter with another letter. But what is that letter? It depends on the key value K. So initially they have taken a ciphertext letter which is standing 3 letters further down in the alphabet. So that is nothing but, if you consider the alphabet A to Z, so any letter is replaced with the another letter. So that letter is 3 places further down to that alphabet. For example, if you take a plain text letter H, H can be replaced by plus 3, that is K. 1, 2, 3, the third letter after that H is replaced. So this we can write mathematically as ciphertext letter C equal to plain text letter P plus 3 mod 26. So here we are performing some mathematical calculation. So we need to convert the plain text letter into integers. For this purpose, we are assigning numbers to these alphabet, A to Z alphabet. So the number assignment starts from 0 to 25. So A is assigned with 0, B is 1, C is 2, like that Z is 25. So in place of P, whatever the plain text letter we have, so that equivalent number will be placed in place of P. Okay, so let us see how we can do that with the example. Our plain text is meet me tomorrow is the plain text. So what is the first letter in the plain text? M is the first letter. So what is the M equivalent number? 12. M equivalent number is 12. So now substitute that 12 in the equation. 12 plus 3 mod 26. 12 plus 3 is 15. 15 mod 26 equal to 15. What is the equivalent letter for this number 15? That is P. So M is replaced with P. So if you observe this ciphertext letter, wherever you have M in the given plain text, that is replaced with P. So like that, see the next letter E. So what is the equivalent number of E? 4. So substitute that in the given formula, that is 4 plus 3 mod 26, that is 7. 7 mod 26 is equal to 7. What is the equivalent letter of this 7? H. So in the given plain text, wherever you have E, that is replaced with H. See here, wherever you have E, that is replaced with H. So this process repeats until we get all the ciphertext letters for the given plain text letters. So but here it is very simple to perform the cryptanalysis. So once if the attacker knows the procedure, that means if the user uses the Caesar cipher, once he knows that the user uses the Caesar cipher algorithm, he can easily decrypt that because the key is fixed 3. So that it is generalized to K. So that is ciphertext C equal to P plus plain text letter P plus key value. So here it is a user choice. It is not fixed to 3. So here where K value is between 1 to 25. The range of the K value is 1 to 25. The user can choose K value as any number between 1 to 25. So now coming to the decryption process. So as I already told in the encryption and decryption process, the algorithm is same but in the reverse order. So here in the ciphertext, to get the ciphertext, we are adding the key value to the plain text letter. So in the decryption process, to get the plain text, we need to subtract the key value from the ciphertext. Okay. So example, in this, what is the ciphertext letter P? What is the equivalent number of P? 15. So 15 minus, for example, K value is 3. Here when we converted plain text to ciphertext in this example, here we used the K value is 3. So that 15 minus 3 mod 26. So that is 12 mod 26 equal to 12. What is the equivalent letter of 12? M. So the plain text letter is M. Okay, so this is the decryption process. So here why we are doing modular division with 26? Because the replacing letters also between A to Z. Between A to Z. So to get the letter between A to Z, we need to do modular division with 26 because the letters numbers are 0 to 25. So for example, the letter is one of the plain text letter. Suppose if one of the plain text letter is Y. So what is the equivalent number of Y? 24. So 24 plus key value 3 mod 26. That is 27 mod 26. 27 mod 26 equal to 1. So that means the number is equivalent to the letter B. So again it is repeating. Okay. So to get this process, we are doing modular division with 26. So this Caesar cipher is very easy technique and at the same time it is very easy to crack the method. Okay. So because the people can perform the brute force cryptanalysis attack. Okay. What is meant by brute force attack? So it is trying for every possibility. That means without knowing the key, the attacker try to get the plain text from the ciphertext by substituting all possible keys. What are the possible keys in the Caesar cipher? Only the K value is between 1 to 25. So initially, this procedure starts from K equal to 1. The attacker substitute K value 1 in place of the decryption process and he will get all the letters. If that letters are giving the meaningful sentences, then they can decide that that is the plain text. Otherwise, they will choose the next number K equal to 2 and do the process. And he will repeat this process until he will get the meaningful plain text message. Okay. So this process trying for plain text without knowing the key. So he will use every possible key in that process. This is called brute force cryptanalysis. So it is very easy because only 25 possibilities are there for the key. So that 25 times he will check. At one point he will get the plain text. So that's why to improve the complexity, we are moving to the next method, that is monoalphabetic cipher. So in this monoalphabetic cipher, we will have a 26 factorial possible keys. So that means for every time the source and destination will fix for one permutation of A to Z alphabet as a key. For example, if you take our alphabet A to Z and the user can fix this permutation of A to Z alphabets. So, they can fix for, suppose if source side they fix for A is replaced with N. So, wherever you have A in the plain text, that will be replaced with N. Wherever you have B in the plain text, that will be replaced with P. So, like that, the source side fixed this ciphertext letters. So, the same sequence should known to the destination side to perform the decryption process. But what is this sequence? It is one of the A to Z permutation sequence. So, like that, how many possible permutations we may have? 26 factorial. So, for A, how many possibilities are there to choose one letter as a ciphertext letter? 26 possibilities. Next, for B, 25, because already one is fixed for A. So, the remaining alphabets are 25. Like that, for C, we have 24. So, when we are taking this, it is equivalent to 26 factorial. So, we can say the possible number of keys are increased. It is to 26 factorial. Okay, so let's see how we can convert plain text to ciphertext by using this monoalphabetic cipher. So, here in this example, I fixed for this ciphertext letters. Okay, so my plain text is meet me tomorrow. So, first I will take the first letter M. So, what is the fixed ciphertext letter for M? So, it is L. So, I am writing L wherever I have M. Then, what is the next letter? E. What is the fixed ciphertext letter for E? V. So, I am just substituting or replacing. The substitution technique is nothing but replacing E with V. Next, T. The fixed ciphertext letter I have chosen is A. T is replaced with A. And for O, it is P. For R, W. For O, P. W is G. So, this is my ciphertext letters of the given plain text using monoalphabetic. Okay, so this is the key. So, in my conversion, I have used this as a key. So, it may vary, depends on the user choice. So, but how many choices are there for user? 26 factorial. You can choose any one of those 26 factorial keys. So, it is somewhat complex when compared with the Caesar cipher. Still, the attacker can perform the letter frequency cryptanalysis. So, letter frequency means in English sentences, every letter is having some standard frequency. For example, if A appears 26% of times in the English sentences. So, if any ciphertext letter frequency is matching with that A letter frequency, then the attacker replaces that ciphertext letter with A. So, like that, he will choose the possibilities based on the letter frequency. So, at some point, he may get the plain text. Without knowing the key, he is trying to analyze the plain text. So, that we are moving to the next method, that is called playfair. So, till now we discussed about Caesar cipher and monoalphabetic cipher. So, in this we converted letter by letter, single letter at a time. The Caesars in playfair technique, we can convert two letters at a time. So, that's why we can call it as a multi-letter encryption cipher. And in this, it divides the given plain text into blocks. The block contains two letters. That is called a diagram. So, it considers the diagram as one unit and it will convert that at a time. And for this conversion, playfair uses a 5x5 letter matrix. But this 5x5 letter matrix constructed based on the keyword. Let us see the example. How can we construct a 5x5 letter matrix? By using the keyword crypto. So, I am taking a 5x5 matrix. So, first we need to fill. This matrix contains the letters between A to Z. This matrix contains letters between A to Z. But we are not filling the letters in sequence. First, we are filling these cells of the matrix with the keyword letters. The keyword letters are C, R, Y, P, T, O. If any letter is repeated in the keyword, we should not write it again. Only once you have to write that letter. So, the remaining cells are filled with the remaining alphabets. See, first alphabet A. A is not there in the given keyword, that's why I am writing A. Next, writing B. C is already existed in the matrix. So, C is already existed in the matrix. That's why I'm not writing C again. Next, D. E. F. G. H. I. J. So, why I and J are sharing a single cell? Because in the alphabet we have 26 letters are there. But the 5x5 matrix can accommodate only 25 letters. That means 2 letters should occupy single cell. So, here I and J, in this process, I and J occupies a single cell. Next, K, L, M, N. O is already existed. So, I am not writing O. P also already existed. Q, R already existed. So, I am not writing R again. Yes, T already existed, so I am not writing T again. U, V, W, X, Y already existed, so I am writing Z. So like this, we need to prepare a 5x5 matrix. So construct a 5x5 matrix with the given keyword. Okay, so let's see how can we convert the given plain text by using this matrix. So this is my 5x5 matrix and my plain text is meet me tomorrow, and we will see how we can convert this plain text into ciphertext using Playfair method. The first step is we need to divide this plain text into two letters. Okay, so that is called diagrams. Divide this into diagrams. So I am writing ME, ET is one block, ME is another block, TO, MO, RR, OW. So in this, if any block contains the same letters, then we need to separate those letters by filling a filler letter X. So where we have the same letters, here RR, same, the block contains the same letters. Then RX, and the second R pair with the next letter O, and we have a single letter remains, so that will be filled with the another letter, filler letter called X. So like this you need to prepare the diagrams first. Then in the third step we need to take one by one a diagram and convert by using the 5x5 matrix. So for this conversion we need to observe where the two letters existed in the 5x5 matrix, whether they are in the same column or they are in the same row or they are in the different rows and columns. So first take the first pair ME, where M, we have M here, and E. So they are not in the same column, they are not in the same row, they are in different rows and columns. So in that case, the letter will be replaced by a intersection point of those two letters. Here in this example, you need to replace M by the intersection point of M row and E column. M row and E column. So what is the intersection point letter? S. So M is replaced with S. Next, then how E can be replaced? You need to consider E row and M column. E row and M column. What is the intersection point? Letter A. So E is replaced with A. So like this we can convert M, E. So from this what we can observe, when the two letters are in different rows and different columns, you need to take their row and column intersection point. To replace M, so what I am taking? M row and E column intersection point. To replace E, what I considered? E row and M column intersection point. So that is SA. M and E are replaced with SA. So see the next diagram. The next diagram is ET, where that E and T are in the 5x5 matrix ET. So both are in the same column. When the two letters are in the same column, they will be replaced by their immediately below letter. So that means E is replaced by K, T is replaced by E. E is replaced by K and T is replaced by E. K, E. E and T are replaced by K and E because they fall in the same column. Next, ME. ME we already replaced, so we can replace with the same letters, SA. Next, TO, where T and O in the matrix here. So they are in the two different rows and columns. In this case, how can we replace the letters? So if a T should be replaced means it's row and column. T row and O column intersection point. T row and O column intersection point C. T is replaced by C. Next, O. O is replaced by the intersection point of O row and T column. So O row and T column, the intersection point E. So O is replaced by E. So like this we can replace when they have in two different rows and columns. Next, M and O. So where M and O? Two different rows and columns. So M can be replaced by the intersection point of M row and O column, that is L. And O is replaced by O row and M column, that is E. Next, R and X. R is here, X is here. So R is replaced by P, X is replaced by V. Next, W and X. So now W and X are in the same. We already seen two cases. One case is the letters in the two letters are in two different columns and rows, or the two letters are in the same column. Now W and X are in the same row. When they are in the same row, so how we can replace the letters? Each letter is replaced by its immediate next letter. Okay, that means W is replaced by X, X is replaced by W is replaced by X, X is replaced by Z. So you can write instead of W, it is replaced by X. Instead of X, it is replaced by Z. Okay, so we can observe three cases to convert these diagrams or to convert the plain text into ciphertext using this 5x5 matrix. So what are the three cases? First case, if they are in the same row, the letters, each letter in the diagram is replaced by its immediate next letter. The second case, if they are in the same column, then each letter in the diagram is replaced by its immediately below letter. If they are in the two different rows and columns, they are replaced by that letters row and the other letters column intersection point. Like that, we can replace plain text letters into ciphertext letters. So now we can consider this is our ciphertext of given plain text. So in today's lecture, we discussed about Caesar cipher, monoalphabetic cipher and playfair. So next lecture, we will discuss the remaining three substitution techniques. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.